Hi everyone, welcome to this lesson on linear motion with variable forces. Now you can see that I've got the equations of motion over here with a big red line through them on the side. These equations were developed, remember, for constant acceleration. If we can't use these anymore, if the force is varying, then that means the acceleration is varying. Now we can still use, of course, Newton's second law. The resulting force on an object equals mass by acceleration. The definition of acceleration as dv over dt, and that v equals dx dt. These are all true, no matter whether the force is constant or variable. Now let's take a look at a quick example of a question here that we could try. Here's one. I'll just read it through as I take some notes. So we've been told here that we have a 3 kilogram object, m equals 3, initially at rest. So that tells me that the velocity of the object when t equals 0 acted upon by a force that varies with time according to this expression. So force is variable and it equals the sine of 3t take 2. T is seconds, force is newtons. We need to find velocity as a function of time. This is our job, find velocity as a function of time. Well, let's see how we would go. Oh, and after that, calculate velocity when t equals 1. So they then want us to use our answer to find velocity when t equals 1. Okay, so what are we going to do? Well, I think we'll use Newton's second law to start off by writing mass by acceleration instead of force equals the sine of 3t take 2. We were told that mass was 3, so if I was to divide through by 3, I would have 1/3 by the sine of 3t take 2, and that would have left acceleration. But acceleration as a derivative is dv dt. This is working okay. I have time as a variable to work with, and this has introduced dt. That's good. Let's separate these variables. dv would equal 1/3 by the sine of 3t take 2, and I've moved the dt, and we'll integrate both sides of this expression. Integral of dv is v. Now the 1/3 there is a constant which will spectate as everything else happens. The integral of sine is negative cosine of 3t take 2, and then we have to divide this by the derivative of 3t take 2, which is divided by 3, and there's a constant of integration. So my formula then is v equals negative cosine 3t subtract 2 over 9 plus c. Let's just call that equation 1. We'll come back to that. We are going to substitute. We were told up here that the initial velocity was 0. So we will substitute t equals 0 and v equals 0. Negative cosine. Now 3 times nothing is nothing, but there'd still be a negative 2 there, over 9 plus c. Well, that's the cosine of negative 2 over 9 equals c. And remember that the cosine of a negative angle is the same as the cosine of the angle. Cosine of 2 over 9 equals c. From 1 then, my formula for velocity would read v equals, why can't I scroll back? There it is. Negative cosine 3t take 2 over 9 plus my constant of integration is the cosine of 2 over 9. And then we were supposed to calculate the velocity of the object when t equaled 1. So the velocity when t equaled 1, well, we'll literally substitute here, won't we? Cosine of 3 times 1 is 3, take 2, plus the cosine of 2, and it's all over a common denominator of 9. So I'll have the cosine of 2 subtract the cosine of 1 over 9. And I believe that comes to negative 0.11. And as everything was in SI units, the result will also be in SI units. So there's a quick example of how we might do the solution to one of these variable force problems. We were fortunate here that we ended up with acceleration as a function of time. And because acceleration is dv over dt, that immediately gave me the idea of getting velocity as a function of time. I have v and t to work with. Now that sometimes doesn't happen, but that's enough for this one. I'll do another one in a moment with some different, a different type of expression to work with. Thanks for watching.